Welcome to the final presentation for Rural Advancement Foundation International, or RAFI. Here's an overview of our project. So to start out with is our team. We had one external mentor, Aaron Johnson, a senior program manager at RAFI, one internal mentor, Todd Neef, who works with the UChicago Data Science Institute, and one TA, Rita Shu, who is also a master's student. There were 4 of us students working on it, evenly split between undergraduate and graduate students. So some background on our project. We worked with RAFI, but RAFI deals with many issues as it's a large organization in the livestock farming industry. And so we specifically worked under the Challenging Corporate Power Initiative. And to this end, we had 2 main work streams, one in livestock auction houses and one in poultry farming. Before we delve into that deeper, some context as to the meatpacking industry, it's essentially split between 2 main components. There's the farmers and the processors. So the farmers are the people that actually raise the animals, and they don't really turn that animal into an end market product. They have to go through something known as a processor who buys that animal from the farmer, and then they turn it into what you would see in a supermarket, for example. And there's 2 main issues split between poultry farmers and other livestock farmers. On the poultry side, essentially due to various logistical reasons, farmers can only transport their chickens about up to 60 miles, and due to this, there are a limited number of processing plants that these farmers have to sell their product to. And so you have this issue of concentration, where essentially you get what is known as an oligopsony, where there's only a few buyers. And then from that, there's various economic downsides, specifically negatively impacting those poultry farmers. On the other livestock side of things, the farmers essentially currently sell their animals through these relatively obscure contracts with the processors. And so we worked at looking at a potential solution in the form of auction houses that would bring transparency to this relatively obscure marketplace. And so delving into the work streams a little bit deeper, first off, on the poultry side of things, we have a market capture dashboard where essentially we took an existing dashboard that showed market capture in poultry processing, and we improved upon it by increasing accuracy. And through this dashboard, what we can do is we can highlight the areas that farmers only have access to 1 or 2 plants. And so we can look at areas where this issue is particularly profound. And then from this, there's ultimately an increased awareness of the issue, but then there's also the potential for regulatory change. Additionally, on the livestock auction house side of things, we essentially created an interactive dashboard that showed a time series of auction house data. And so auction houses are a way for us to bring transparency to these currently obscure livestock contracts. And finally, the dashboard on auction houses and it actually was used as a resource by our external mentor to show auction house trends during meetings with regulatory agencies.
So the first part of our work is we use a merge and clean dataset to build a streamlined dashboard. So we want to visualize time series and geospatial trends of auction houses so that we can determine whether there's evidence of concentration in auction houses. In the end, we want our client to use our dashboard to support digital transparency of livestock contracts. It protects farmers from unfair prices. So we use 2022 NATS database, filter it to livestock auction house only, added opening year and closing year, and generate auction house data. It contains annual revenue coordinates, opening and closing year for 3,455 auction houses. And based on this dataset, we generate annual flux dataset. It contains the count of opening and closing auction houses per year from 1991 to 2021. Using these 2 datasets, we build our streamlined dashboard. So on the left side is our sidebar. Within the sidebar, there are different filters that allow us to look at data from a certain year range or a certain geographic area. On the right side is our main panel. There are different visualizations in the main panel. Each visualization reflects an aspect of the whole auction house industry trend. So our main result is the auction house industry is highly concentrated. These 2 plots basically tell us that from 1990 to 2022, across the US, the total revenue and total count of auction houses declined overall. Revenue per auction house increased from 2008, and median revenue declined from 2018. The first 3 results shows that directly that this industry is becoming highly concentrated, and the declination of median revenue tells us that the industry is becoming more and more polarized, that the companies in the middle part actually shrank. It also supports our hypothesis of concentration. Our client area actually uses our dashboard in its meeting with federal regulatory agency to advocate for digital transparency of livestock auction houses contracts. Thank you.
For this part of our work, we are using a computer vision model to get better estimations of poultry barns for our current dashboard for the poultry processing industry. Previously, we have created a dashboard here, trying to estimate the number of farmers impacted by market concentration in the poultry processing industry. Given lack of data, the market revenue in the dashboard was roughly estimated by employee numbers, which was sort of unreliable. To achieve a more accurate outcome, we thought it would be better to estimate the revenue by getting a count of the number of farms in a specified area. As we have no dataset that lists all poultry barns, we decided to use a computer vision model from Microsoft to pinpoint the locations of poultry barns using area photographs so that we can get a relatively accurate number of count. However, there are some limitations of the computer vision model we used. We observed a relatively high false positive rates in the initial predictions, especially in areas such as coastlines and airports. For example, as you can see in the image, the model tends to mistakenly identify long shapes along the coastline as poultry barns. Therefore, we applied a rule-based filtering on model predictions to identify those false positives in predicted results to achieve a more accurate distribution of poultry barn. Our approach of rule-based filtering involves several steps. Firstly, we utilized existing datasets to eliminate barns in major false positive areas, including downtown regions, coastlines, water bodies, and airport areas. And then we employed the Google Earth engine for more nuanced land cover label filtering. And finally, we integrated the filtered results to a map for visualization to manually examine the points eliminated by our rule-based filtering.
So there are four main types of rules in which we applied in order to filter out false positives within the predictions. And specifically, we were using North Carolina as our primary example because there are a lot of predictions within North Carolina, and that's also where our partner is the most familiar with in terms of like poultry barn distribution. So we can sanity check. So the first two rules is based on coastline and water bodies. We're able to find geospatial data online, and we were able to join coastlines with the current predictions in order to filter out some of these false positives here, because it's pretty unlikely that there are poultry barns along the coastlines or in these water. We found a total of 400 barns in the coastline area and about 1,022 in water, and we went through them to make sure that there's actually no barns in those regions. You can see that most of them are being filtered out while a couple are still left, mainly because the data that we were using wasn't granular enough to cover all of them. And two other rules in which we added is a downtown area within North Carolina as well as airport area. So we found a total of 190 barns in downtown Charlotte and Raleigh, and we filtered them out because it's unlikely that there are poultry barns within metro areas of North Carolina. Similarly, we found about 211 barns in airport and its surroundings, so all of these are being filtered out. We actually manually went through these barns to make sure that the false positives are indeed false positives. So there are a couple of different types that the model is very likely to identify as a prediction when in reality it's not. So one type is apartment buildings in metro areas. So you can see here they're like long skinny rectangles, and really they're not poultry bars but just buildings. Similar things happening with stadium border as well as parking lot border. So all of these borders are kind of long and skinny and rectangular shaped. So that's why the model was incorrectly identifying them, and we're able to eliminate that in our filtering process. So just to give a quick summary of the overall, filtering steps, we actually were able to remove about 10% of the predicted barns. So our original prediction was 22,000 barns. And after excluding all of the water, coastline, downtown region, and airport, we are left with 20,000 barns. So you can see all of these coastlines and like downtown Charlotte, downtown Raleigh were all filtered out. There are still some left because, again, our data isn't necessarily granular enough, which is why we actually ended up using another layer of filtering by calling the Google Earth Engine API, in which we will ask the API to give us a label. So some of the water area that we were missing was being filtered out by this last step as well. Okay. So just to summarize what we've done this past quarter, our work is twofold. First, we made a livestock auction dashboard in which we're able to visualize time series data on auction houses. We also improved the model accuracy by eliminating false positives, thereby helping increase the accuracy on the overall poultry market capture data. So in general, we were able just to create a more accurate dashboard and an accurate view to show livestock concentration for RAFI. In terms of future steps, we're hoping to look into additional data sets and understand how exactly the livestock industry is distributed. We also hope to add more filtering rules and maybe even retrain the Microsoft model in order to get better improvements. So overall, I think RAFI would definitely be able to utilize this dashboard in order to advocate for future meaningful policy changes in the livestock industry. Thank you so much.